While most of NASA's facilities remain in silence during the government shutdown, a handful of scientists continue their watch over a mysterious traveler moving away from the Sun. Its name is 3IATLAS, and though it was first logged as a routine comet, it has since defied nearly every law of celestial mechanics known to science. In dimly lit control rooms at Goddard Space Flight Center and the Jet Propulsion Laboratory, small teams of astronomers keep instruments pointed toward a faint, flickering object. Despite frozen budgets and suspended communication, the data stream never stopped. Numbers arrive encrypted, showing irregular motion, sudden brightening, strange patterns of reflection. Something about Atlas refuses to behave like a normal comet. Congresswoman Anna Paulina Luna has demanded that NASA release the latest images to the public. Harvard astrophysicist Avi Loeb echoes her call for transparency, arguing that the object's recent solar pass revealed phenomena that deserve open scrutiny. And so, while Washington remains paralyzed, telescopes across Earth, from Chile's desert plateaus to the icy domes of Norway, have quietly joined the global campaign now known as Atlas Watch 2025. When the object swung past the Sun on October 29th, its light suddenly flared. The brightness curve didn't rise gradually, it pulsed like a heartbeat. Spectral data captured bursts of water vapor, carbon dioxide, and traces of nickel, but they erupted from one hemisphere only. Typical comets vent chaotically. ATLAS vented as if something controlled the direction. Stranger still, no tail formed. Hubble's instruments recorded a sharp, clean glow, and the James Webb Space Telescope detected spectral lines that vanished too quickly to match natural materials. The glow faded, then returned, steady, precise, artificial in rhythm if not in proof. By early November, JPL confirmed that the comet had drifted from its predicted orbit by 4 arcseconds, about 80 kilometers off course. The deviation sounds trivial until one realizes the scale. An object the size of a small mountain pushed sideways through space by forces no comet should experience. The acceleration measured 0.2 millimeters per second squared, enough to move the object 80 kilometers in a month. Even more baffling, the push came from 2 directions at once, outward from the Sun and sideways along its orbital path. Comets don't do that, Loeb ran the numbers. If that acceleration were due to outgassing, the release of heated gases as ice turns to vapor, Atlas would have to lose 5 billion tons of material in weeks. That much mass would create a massive cloud brighter than the comet itself, yet telescopes saw nothing. Its halo remained compact, reflective, unnaturally blue. Polarization studies showed that light scattered from its surface like metal, not dust. Nickel dominated over iron, a ratio common in engineered alloys used for spacecraft. Some speculated the data were wrong. Loeb countered simply, "When theory breaks against observation, it's the theory that must yield." The anomalies kept multiplying. The object's orbit was too perfect, tilted just 5 degrees from the plane of Earth's planets, so unlikely that the odds border on impossible. Its brightness doubled faster than any comet ever recorded. Its jet fired toward the Sun instead of away, and its rotation matched no known model. When plotted backward, its trajectory traced directly through the same region of sky where the 1977 WOW radio signal originated. Perhaps coincidence, perhaps not. As government agencies scrambled to control public speculation, social media filled the vacuum. Atlas signal trended for days. Rumors of hidden data, secret frequencies, and artificial propulsion spread like wildfire. NASA and the Pentagon's All-Domain Anomaly Resolution Office issued a terse joint statement. 3IATLAS is fully identified and poses no threat. The line did little to quiet curiosity. Inside congressional briefings, officials hinted at non-standard optical behavior. No further comment followed. Meanwhile, the European Space Agency, the Chinese FAST telescope, and Arizona's Lel Observatory began coordinated observations. In late November, a set of radio readings revealed faint rhythmic pulses, 12-second intervals spaced by a golden ratio pattern of frequencies, the same sequence found in biological growth and galactic arms. Most scientists dismissed it as structured noise, but Loeb called it a whisper from the void. Speculation turned philosophical. If Atlas is not a comet, could it be debris from a probe? A relic of a civilization long gone, drifting between stars, its reflective panels catching the sunlight of a new system? Perhaps its acceleration wasn't caused by jets of gas, but by residual photon pressure on an ancient sail, one still functioning after eons. Its sudden brightening could have been a reactivation, a dying system flickering back to life as it felt another sun. The idea sounds like science fiction, yet history reminds us that yesterday's fiction often becomes today's physics. Voyager 1 is already an interstellar artifact. Imagine another civilization watching it and wondering the same thing we are now. Regardless of origin, 3IATLAS has already transformed astronomy. It proves that fragments from other stars regularly enter our solar system, carrying chemical fingerprints from alien worlds. Its isotopic ratios differ from ours, hinting at colder, more distant birthplaces. Its spectral color, an impossible electric blue, suggests materials never seen in natural comets. Every new image forces scientists to expand their definitions of what a comet, or even a planet, can be. Despite the shutdown, NASA confirmed that all collected data will eventually be declassified. The International Asteroid Warning Network will keep tracking through January 2026 until the comet fades beyond detection. By February, it will vanish into the darkness between stars, leaving only petabytes of raw data and a trail of unanswered questions. Yet its influence will endure. Engineers are already designing the Sentinel program, an array of robotic telescopes ready to swing toward the next interstellar visitor. The Vera Rubin Observatory will soon scan the entire sky every 2 nights, promising that events like 3IATLAS will no longer be once-in-a-decade miracles, but regular opportunities to study the messengers that cross the galaxy. 3IATLAS may disappear from sight, but its story has only begun. It united scientists, politicians, and dreamers in a shared moment of awe, forcing humanity to confront an unsettling possibility. That somewhere in the dark, something might be watching back. When asked what he truly believes Atlas to be, Avi Loeb gave a quiet answer that still echoes across lecture halls and podcasts alike. If it's natural, we've discovered a new kind of physics. If it's not, we've made first contact. And maybe, just maybe, that blue glimmer slipping into the night isn't running away from us at all, but going home. The 3IATLAS event has become a mirror for humanity's future. It forced us to confront how little we know about the universe, and how much more we still dare to imagine. The coming decade will not just be about discovery, but interpretation. Every comet, every anomaly, every flicker of light across the void will now carry the question Atlas left behind. Are we alone, or merely late to the conversation? Whatever the answer, our outlook has changed forever. Because once you've seen something that shouldn't exist, you start to wonder what else is out there, watching the watchers.